Welcome back guys to another episode of RoboCNC. I'm Marcel. Today we're gonna mount the anti-backlash rack and pinion system we built in an earlier video. If you've not seen the earlier video, click on the link in the top of your screen to see how we build up this unit. Today we're gonna mount it on the RoboCNC X2 router. And we're gonna show you some movement. I'm not gonna do a full intensive testing on this unit. This is purely on mounting it to the router, and of course now finally we can see some movement in the machine. So let's jump into it. Well, to start off, a rack and pinion system of course needs a rack to ride on. We're going to use this Module 2 type rack. We're going to mount it on the item profiles into the slots with this T-slot nuts for M5 bolts. To align the rack to the CNC machine, I'm going to use this articulating arm on a magnetic base. And I'm going to use a dial test indicator to align it. When you're doing stuff like this, most of the times you have the option of choosing what type of measuring tool you're going to need. So for now, I'm going to use a dial test indicator with the divisions of 1/100th of a millimeter, which is about the 1/1000th of an inch. So I'm mounting the rack to the CNC machine in the upper slot, and I'm mounting it with the teeth pointing down. And the reason for this is that I do not want dust and small debris to clog up the teeth of the rack. So I'm mounting the magnetic base to the gantry. And I'm going to use the gantry to align the rack to the CNC machine. So the rack can still move quite a bit in this top slot, and I'm just gonna eyeball it to be somewhere in the middle of the slot and then tighten the first bolt. I'm gonna move the dial test indicator to be close to this first bolt and call this the 0 point. I'm adjusting the needle to be close to the 0. Now I move the gantry to the next bolt, use my hands to push the rack up or down to reach the 0 on the dial test indicator, and then tighten the second bolt. So I'm doing this for the complete length of the rack. I'm just trying to get it close to the 0 point so that the rack is level all across. Then I tighten the bolts, not really tighten them, but just hand tight to keep the rack from moving. So next I go back to the first position, set the dial test indicator back to 0 and check every exact bolt location. I'm using a small plastic hammer to tap it really into alignment and then tighten the bolt further so that it really doesn't move anymore. Doing a sanity check and up to the next one. I'm trying to get every bolt within 1/100th of a millimeter from the zero spot. So here we have the Anti-Backlash rack and pinion systems, the left version and the right version. So make sure you use the correct one on the correct side of the machine. Well, before we mount it, we make sure that the tensioner is completely loose. So one of the pinions can still rotate quite a bit freely. So now it's time to mount this unit. The pins you see here are used to align the unit to the top of the rack. And for now I'm just gonna lay it on top of the rack and insert the 4 Allen bolts. You do not have to really tighten the bolts since we're still going to align the unit, but just put the 4 in almost to its final position. Let me speed things up a bit. So that's number 4. Now to align the unit in its correct height position, we're gonna need some feeler gauges like this. And this is a standard feeler gauge set you can find all over the place, and you need 2 of these sets. For me, I got my hands on some long feeler gauges, so I can go with 1 set, but these are somewhat less easy to find. I'm going to use a 0.2 millimeter thick feeler gauge. And I'm going to place it on top of the rack and under the 2 alignment pins. So what I'm doing here is aligning the unit to the rack, but keeping a small gap between the pins and the rack, a gap of 0.2 millimeters. This is the correct gap to get the pinions in the correct place for the rack. Now we can tighten the 4 bolts. Don't forget to take out the feeler gauge, of course. So step 1 is done in mounting the rack and pinion system. I have one side placed on the gantry, and yet I have only set the height of the unit by the set pins and the feeler gauge. So next up is to make sure that the pinions, these two, are grabbing into the teeth of the rack. If you've not seen the assembly of this rack and pinion system, this zero-backlash rack and pinion system, hit the link in the top of your screen and have a look at that video first to see what's inside this unit. Well, what's important to know in front of time is that the primary pinion, the one that's connected to the shaft into this gearbox, cannot be rotated from this side. Since this is a worm gear, we cannot rotate it from this side. If I want to rotate this one, I will have to take my fingers and take the primary input shaft of the gearbox, so the place where normally the stepper motor would connect to. And if I rotate this, you see the pinion starts rotating. The other side is loose. And the reason this is loose is because the only thing that makes this rotate is a timing belt that's inside this unit. And the timing belt has some slack in it. So this is why we can still rotate this pinion gear. To take the slack out of the timing belt, I can use this bolt down here. If I tension the nuts on this bolt, I will tension the timing belt, and that will rotate this pinion in this direction. So basically the two pinions are rotating toward each other on the top. So on the side where the teeth are, because the teeth are on the bottom side of the rack, and they grab into the top side of the pinions, they grab like this. So they pinch down the teeth. So they do not push outwards, they pinch to the middle. Something to take note of in your head. Important before doing this, to make sure these teeth are already quite good in alignment. And I've shown that in the previous video, or not the previous video, but the one I linked to in the screen, in the assembly of this unit. So before making these bolts for the toe lock grab, we have to align it with a small piece of rack, or with a long piece, doesn't matter, but make sure these are already quite in alignment for the rack and pinion system, or the rack. So if we tighten this nuts and we tighten the belt, it's only a small piece of slack that has to be taken out of the timing belt. So for this side, this is the first side we're gonna do. When I start rotating the nuts, I will tension the belt. The pulleys will rotate against each other, or basically one will rotate and the other will stay stationary, and they will grab some teeth. The bridge can still move, so it will just align itself and go wherever he wants to go, and then pinch the rack. When I go to the other side, I have to be a bit more careful, because when I want to pinch the teeth, the bridge cannot really go from left to right, since it's already fixed on this side. So first I will take out some slack by rotating this by hand and making sure that I rotate this pinion in the direction towards the middle. So in my case I have to rotate to the left to rotate this pinion to the middle. And if it grabs, it is against a teeth, then I can take out the slack here, and this one will rotate that way, and then we pinch the complete rack without trying to misalign the complete bridge. I hope it makes sense. But well, let's just do it. So time to adjust the pinion gears of the first side of the bridge. So still there's a lot of play. I've mounted an indicator on this side, dial indicator, to see how much backlash there is. And I'm not even going to tell you because it's a lot, like so. This is the first side, so the gantry can go whatever direction it wants to go, doesn't really matter. So I can just tension the tensioner and it will square itself up and grab or pinch the teeth on the rack. Take the first nut off for a second and the second nut. With the second nut I'm going to tension the system. So the needle on the dial indicator stopped moving, so I'm gonna check. There's still a little bit in there. Gonna put a little bit more tension on there, half of a turn, and feel. And there's really nothing in there. Maybe some wiggle flex, but maybe a thousandth of a millimeter, but I can really not. I can hardly see it move. So I'm gonna leave it like this for this side. I'm gonna put the second nut on there. And these two will tighten together to prevent the first one from moving. Keep it in place. Oh. Tighten the second one without moving the first one. Just lock them together. And this one's done. Up to the other side. So I'm cramped up on the back side of the machine. Again, this unit is placed and it's aligned for the height with the feeler gauge. The pulleys are not yet grabbing into the rack. Now the gantry is basically steady. Of course it can be a little bit crooked, that's not a real big problem for now, but I'm gonna try to keep it aligned. The gantry, the bridge, is on 4 heaving carriages, so it wants to be straight. It wants to be square with the machine, and I'm gonna try to keep it that way for now. So the first thing I'm going to do is take the slack out of the primary shaft. I'm gonna rotate the input shaft, the one that the stepper motor is normally connected to. And I'm gonna rotate it so that the primary, the one in line with this shaft, the one on your side, is rotating towards me on the top. So it's rotating towards a teeth. And for me that's rotating this one to the left. And I can feel and see the indicator move. So I know it starts moving on the indicator towards me. So I am pushing against the gantry. So I'm gonna leave the primary one for now. And now it's time to start tensioning the one on my side, which will rotate towards you and that way pinch the rack. So again, I can see on the indicator, I don't think you can see, but I can see there's about 0.2 of a millimeter play. I can move it 0.2 of a millimeter from side to side. So what I'm gonna do is tension the first nut. Until I don't see the indicator moving. Which is already now. Still. Half a tenth. Still a bit. And we're there. Less than 100th of a millimeter space when I push. And basically that could be flex inside the machine. I'm pushing against it with a lot of weight and it's hard to test it like this. But let's give it a small bit more, like so, and now put the second nut on. So lock together, check, no play, good to go. Up to the next step. Up for mounting the stepper motor now. I removed these NEMA 34 stepper brackets for now, because on this shaft is a key, and the couplers I'm going to use are not suited for using a key like this. So I'm going to remove that, or at least try it, because I really hate this. But with a pair of grippers, if you buy grippers, never buy the ones with the moving jaw. Really. So I removed the key and I placed back the mounting brackets for the NEMA 34 motor, which were supplied with the kit. Now it's time to place the coupler. Again, it's a DCNC coupler, a Damen CNC coupler, zero backlash. Really love these guys. But this is the bigger version, so it's a 40mm diameter and 65mm in length. So first of all, I take note of the place of these bolts and put them basically in opposite direction. Close the coupler, so both bolts are over here but in opposite direction. This makes it more easy to assemble it. Just gonna place it over the shaft and leave it for now. time to place the stepper motor. So, and the last one, like so. Okay, so now just eyeball the coupler to be somewhere in the middle and tighten the bolts with an Allen wrench. So off camera I did the wiring of this stepper motor. Not gonna go into the electronics in this video all that much, although I do want to say I really like this type of stepper motor design due to the connection above. It's just a screw terminal connection type, and it's isolation protection IP54. Which I don't really need for this application, but I do like the design. So the last thing to do is to place the sensor, which will be at this position. I'm not going to use the sensor Damen CNC supplied with it. I'm not going to argue in this video why I go this route, but basically I want to use an NPN sensor, and supplied is a PNP type sensor. Fine, if you want to use that, I want to use this one. I do use the same brand, which is just really a better choice than the cheap Chinese versions. It's an inductive sensor, so it senses metal. So for now I'm not gonna make a difficult block or something. I'm just gonna use a profile nut and a small M6 bolt to place in this slot, and when the sensor comes over the bolt it should sense it. Or less, I think it will. So let me place this one. For now, I'm placing it in the back of this slot, just to be able to align the sensor in height. The nuts that came with the sensor and the ones that came with the unit didn't fit in this slot, which is quite strange. So I had to file them down a little bit to make them fit. Put one on there. Place it in. One nut on the other side. So the bolt and the sensor are quite close together. I think I have a gap of about 1 or 1.5 millimeters. Make sure to look in the data sheet of the sensor you use. what the sensing distance is, the maximum sensing distance. So you do not want it to hit the bolt and you do not want it to miss the bolt because the distance is too big. I can basically play a little bit to get a good alignment of my cable. And lock the nut on the other side. So now I can slide this bolt to the beginning of my x-axis, and basically that will be the home position of the CNC machine. Out of self-preservation, I'm gonna explain the step settings that I'm gonna use for this unit, since I think I will get this question a lot, and I think the guys at Damen CNC will also love me for showing this to you guys. So basically we have a normal stepper motor, which is 200 steps per revolution. So the stepper motor has to do 200 steps to do one full turn. On my stepper drives, I have selected a 16 microstep setting. So what this means is that I have 200 times 16 is 3200 steps per revolution at the stepper. So I have a micro stepping set to 16, so 16 times the 200 normal steps is 3200 steps. So I have to send 3200 steps for the stepper motor to do a full revolution. The stepper motor is not connected to the pinion gear, but it's connected to a V40 gearbox. This gearbox, I have selected the reduction ratio of 1 to 10. So for each revolution the pinion has to rotate, the stepper has to rotate 10 revolutions. So again, multiply it. We have 30,000 steps needed to rotate the pinion gear one revolution. The pinion I have selected has 15 teeth at a module 2. This is the type of gear and this is the amount of teeth. Well, with this kind of systems it works like this. You have the module times pi times the teeth is the travel. So what do we have? We have a module 2 times 3 is So module 2 times pi times 15 teeth makes a travel of 49.2477 millimeters. So every revolution the pinion makes, it has a linear travel of this number. So I have to know how many steps per unit. So in my case it's a millimeter. So I want to know how many steps does the stepper motor have to take for 1 millimeter, because this is a setting you have to set in your CNC software. So I know that 32,000 steps is this amount of travel. What I want to know is 1 millimeter, how many steps. So I multiply 1 times 32,000 and divide it by 49.2477. And this makes this is my number. I have to set my software to 339.5 steps per millimeter. So guys, we have movement in all 3 axes. If you want to celebrate with me, please hit the thumbs up button below. I will do a full depth review on these units later on. Still have to do a lot of testing. For now, hit the subscribe button if you're not yet subscribed. And if you want me to point out another video you should have a look at, will be this one. Thanks and bye for now.